Cool. So as Barbara introduced me, my name is Lambodhar Damodaran. I go by Lambo. I'm a postdoc in Louise Moncla's lab at University of Pennsylvania in the vet school. And so my project was tentatively entitled FIDO, Finding Infectious Diseases Online, and obviously relating to dogs. So jumping in, the main motivation behind this project was looking at a major problem that a lot of us are very kind of aware of with pathogens that are poorly sampled or undersampled. So viral pathogens that may not be at the forefront of people's minds, that may not have an imminent human potential or zoonotic potential, are kind of go underreported. And so I wanted to take an approach where we could see if we could use web scrape data from the internet to kind of create a data set and or create a data set that we could actually use to make some epidemiological characterizations in lieu of, centralized reporting and stuff like that. So I chose H3N2 canine influenzas in North America as kind of my case study, following its introduction in 2015, mostly for a couple of reasons. Sorry. So why canine influenza? There is evidence of like burden on the companion pet population in North America. There are some studies that have suggested some zoonotic potential and some adaptation to human airway epithelia. There's research recently out of China. And then the fact that there are just no central repositories that report on cases. There's no mandated reporting from governments, and very few state agencies report are obligated to report. Some of you may have noticed in the last couple of years, there's been like major outbreaks. We see this in the news a lot, but that's kind of where it really stops. Is like we see these outbreaks. People say, "Oh, there's dog flu in this in these shelters," and we say it's a big problem. Some vets try to vaccinate, but there's just very little to go off of because it's all veterinarians that are reporting to like local health agents or to local news reporting agencies. And so my strategy was to see if we could combine web scrape a pseudo case count data is what I call it, and some phylogenetic estimates of population size, given my background in phylogenetics, and see if we could actually develop some epidemiological models to infer case counts and also just epidemiological values like R naught. So I'm kind of breaking down what I've done or so far is I first conducted a literature review, and then I also used a web scraping tool through some Python scripts to collate this pseudo case count data, which I'll describe a little bit more. I also did some phylogenetic reconstruction using BEAST and available sequence data to calculate effective population size, which is our proxy for population size. And then we were also very fortunate to partner with Colin Parrish's lab at Cornell to get some case count data. And then also very, very recently, I was able to find some case count data through a web portal that I'll describe a little bit more. This is all to eventually funnel into an epidemiological characterization, which is currently ongoing, and talk about more. And I'd love to get some feedback or some thoughts on this as well. So the data that we collected, I first conducted a literature review using the PRISMA methodology, identifying very little papers because obviously this is a very undersampled pathogen, so not many papers are there. And part of this is my web scraping. I identified ProMed records, but also web scrape news records. So this is about or 57 records from ProMed. A lot of us are very familiar. It used to be a resource that could be very helpful for identifying outbreaks. And then I got sequence data from GISAID. There's not many sequences, as you can see over this, going back to 2015, it's only about 168. But the whole point of this was to see what we could do with data that was available. So I collated this into and just to visualize this, you can see that there are some significant gaps. So this is going back to 2015, as I said, and these asterisks indicate when a news report maybe said that there was an outbreak but did not give a specific number. And so you can see that there are some significant gaps, but there is some kind of epidemiological, or there is obviously cases that are happening, and especially significant spikes in certain periods. When you actually break down what it looks like, from this web scraping, A lot of it, so the actual news reports from this web scraper filled out a lot of space, but then also ProMed, which kind of underscores that like some of these resources that are kind of going behind paywalls and something are some of the like only information that we have about pathogens. Journals made out a very little part of that data, and then even less so the GISAID sequences because they only really represent one virus at a time. I also did some phylogenetic reconstructions. So the reason why we can do this is just not going to belabor you guys with coalescent theory, but the idea is that if we model a population over time, we can, if we sample it relatively well enough, we can estimate how big a population was overall. And so this is the phylogenetic representation of this time period, and when we actually look at the phylogeny, there's long periods of time where there's actually a lot of missing sequences. We get this very punctuated behavior, and that's just kind of the result of very small groups doing some sequencing and then sharing it, but there's no concerted effort to do regular surveillance and sequencing. We actually look at the epidemic or the effective population size reconstructions. That actually kind of hurts the reconstructions because we end up with these periods where it's very hard to tell if that's just an artifact of less sequence data or there's actual data information there, which is why comparing this to like case count data, if we can get it, or some pseudo case count data is actually really important. And that's something we're going to do soon enough. When it comes to actual case positive data, this is kind of where I think is some of the stuff that is really promising recently that we were able to. So this is, I'm visualizing the pseudo count data, and the data that we got from the Parish lab, which is through the Antec company, it is visualized here, where this is only from 2021 to today, because that's just I just wanted to visualize what we had available, like an actual case positive like testing data that was available. And then recently, this website dogflu.com actually came across, or I came across dogflu.com, and this is through the IDEX company that actually does a lot of testing for most veterinary pathogens. A lot of people might be familiar. I think it's a collaborative effort between Cornell and Merck, I believe, or it's a subsidiary of Merck. But interestingly, they have data, not just like positive data, but also like test initiatives. So you get like negative case or negative tests. And so what I did was I wrote a script to extract all the JSONs out of it, because clicking on each panel would have been a nightmare, and then collated that into the case data. And so what I think some people might be interested in seeing is actually the fact that like there's not a strong concordance between these two different uh, metrics, or sorry, these like case positive metrics. So these two totally different companies, and you're seeing there's not a lot of concordance. So that what is that telling us is that without centralized reporting, getting a clear picture of like the actual burden can be it could be potentially wrong. It could be it could be less informative without a holistic picture. And so one of the things that we're thinking about, or so what we're doing now, is thinking about how we can like visualize this data, but also just combine the data to see if we can do some epidemiological characterizations. And so this kind of gets to where we kind of got to with some modeling. So initially we wanted to do OMP, which is a partially observed Markov process. The reason I wanted to do this in the first place was that it was theoretically flexible enough to capture some of like the unsampled diversity and account for like the fragmentation in the data. But I ended up running into some difficulties in running the package, and so we reached out to some experts that know this package well, and we determined that there's some really important specifications because of the way that the data is structured that we'd have to make, and that would take some more time to actually implement well. And so in the meantime, I ended up looking at other packages, like some packages that people are aware of, like EpiNow2 and EpiEstim2. And so I'm just showing a small snippet here. Like this is using like the Antec data. We can start to we're going to start to look at just using each of these metrics that we've collected, like the pseudo count, the case positive data, the effective population size estimates, to see if we can get some characterizations of like effective population or reproductive number, and so forth. So kind of the big takeaways, without centralized reporting, it's really hard to get a good idea of true burden for a pathogen like this. More sequencing of samples is helpful, and to actually get an adequate genetic characterization of the virus. And then in the absence of case positive data, secondary data sources might offer some insight into where pathogens are occurring and when. And so our next steps are to reconcile some of the duplicated information in the pseudocounts, because there's potentially, especially with like the ProMed versus the news articles, a lot of the like ProMed, it's informed by news articles, just making sure that some of that information is not duplicated. And then especially with the dogflu.com data that we got very, very recently, just visualizing some of the spatiotemporal distributions of cases. Interestingly, too, with that dogflu.com data, there's data for other dog pathogens that I think some people who are vets in the audience might find really interesting, like Bordetella, and seeing just like if there's like co-occurrence or something like that with other important dog pathogens. And then actually like robustly doing these epidemiological estimates, looking at different reporting lags, because that's one thing that's really important. Some of these packages that can help us account for that. And then investigating the seasonality versus if there's any seasonality, or if it's a sporadic driven virus. And so that's it. I think I made it on time. And so thank you so much to Barbara for giving me all of her time and expertise, and just her being a great mentor. I think that Colin Parrish's lab, especially Colin and Brian Wasick, who helped to facilitate some of the data and then gave me some background on canine flu, which was very helpful. And then my PI, Louise Moncla, and then two lab members, Maria and Elena, who did some really important helpful work in getting some of this data together. And then these are my pups, who are my inspiration for doing this project in the first place. So with that, I will pause.